we've made it to y'all's favorite part of the study guide, which is the proofs. Proofs we love because we can get some easy give me points. And so y'all know I love to color coordinate, color code. And so what I always do is I start with my givens and I highlight what is given. I find it in the proof so I can pay attention to where that stuff is at. BC and DC are congruent. AC and EC are congruent, and then I want to make sure I go ahead and write the word given so I get those free points. That was given to me. Then I want to pause and make sure they actually marked that stuff in the picture. So did they? BC is congruent to DC. That is marked as congruent. Fabulous. AC is congruent to EC. That is marked as congruent. Fabulous. Okay? Now we want to look at ultimately what they're trying to prove, because that's going to tell me what I'm going to do next in the proof. They are trying to prove that the two triangles are congruent. So anytime that they are trying to prove that the two triangles are congruent, I can copy that statement right here. And what that means, immediately I know that what is going to go next to that is one of my 5 shortcuts, okay? One of my 5 shortcuts for proving triangles should go right here because I'm proving triangles congruent. So what are my options for proving triangles congruent? I'm going to write them up here. I'm going to write them down here. My options for proving triangles congruent are side, 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 angle, side, angle, side, angle, 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 side, or HL. Those are the 5 that do work. These are ways to prove triangles congruent. To prove triangles congruent. So that's like saying a triangle 1 is congruent to a triangle 2. If you can do that, you're going to use one of those shortcuts. What are the ones that do not work? The ones that do not work are side, side, angle, and then angle, angle, angle. Those are the ones that do not work. So I'm going to put an X on those. Do not prove triangles congruent. So what do you put there? You put not enough information. Okay? So these imply not enough information to prove the triangles congruent. Okay? So I have the ones that work, and then I have the ones that do not work. So I know immediately I should not write any I on a proof, because if you're able to prove them congruent, that means that one of the shortcut works. So let's go look at our picture. Right now, what we have is we have a given side that is congruent and a given side that is congruent. It kind of helps me to organize myself. So I know that between my shortcuts, it's going to probably be one of the ones with 2 S's in it. So I'm thinking either side, 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 angle, side, or possibly HL. But since I don't see a right angle or anything given about a right angle, I know it's not HL. So now we go to the picture and we say, okay, is there any information that I could add? Are these triangles touching or overlapping? The answer is yes. So what can you add? You get to add vertical angles. These vertical angles are going to be congruent. And so that is what we want to do. We want to say, hey, by the vertical angles theorem, we get to add vertical angles in this picture. So I'm going to go angle BCA. I can't just call it angle C because there's more than one coming out of angle C. Angle BCA, so that's first, second, third, is going to be congruent to angle DCE. That's first, second, third. If you want to do that from the picture, that's totally fine. BCA, you go across the one with 1 and then across the one with 2. This picture has been rotated, so whenever you go across, you have to go across the one with 1 and then across the one with 2, so that's going to be DCE. Okay, but use that statement. You've got it there, you might as well use it. And so what shortcut is this going to be? We can already tell from our picture. That is going to be side, angle, side, proves that these triangles are congruent. So the yellow stuff is going to be the easiest because it's given. The blue stuff is going to be pretty easy if you're looking at the picture once you add the information. The pink step, in my opinion, the pink step is the most difficult, but that's the stuff that you are adding to the picture every time. Okay? All right, so let's do that again on question 45. Here's my given stuff. CBA is congruent to DBA. That's an angle. So I'm going to go ahead and write that on there. So I already have an angle. So I know it's probably not going to be side, side, side. Then we have BA bisects this angle. So I know that's probably going to be another set of angles. And that's all that is given so far. So let's go make sure that that's marked in the picture. CBA is congruent to DBA. That's a given. Well, unfortunately, that's not in my picture, so I'm going to have to go mark that. CBA is going to be congruent to DBA. So I'm going to add a single arc on both of those. Those are congruent. Then it says that BA, this segment, BA, bisects angle CAD. Well, where is angle CAD? Angle CAD is right here. Oh gosh. C to A to D is right here. And so if it bisects it, that means it's going to cut it in half. So I get to add tick marks right there. It bisects that, so that angle gets cut in half. And so which angles end up being congruent? Angle CAB is going to be congruent to CAB. Let's look at this. 1, 2, 3. So CAB is 2, 3, 1. So what's that going to be on the other one? 2, 3, 1 is going to be angle DAB. If you read it from the picture, because you go from out to in, we have to do that again, out to in, because it's been flipped over, it's been reflected, and so that's going to be angle DAB. So now we have 2 angles. We've gotten 2 angles on there. Okay, we had our givens, and that ended up giving us 2 angles. Well, do these triangles overlap? And of course, the answer to that question is yes. We've already kind of highlighted this side. They overlap at this side. And so by the reflexive property of congruence, I can say that that side length AB, which is 3, 1 in this statement, so use your congruent statement if you need to, 3 to 1 is going to be congruent to 3 to 1 again, which is AB. So AB is going to be congruent to AB is going to be congruent to AB. That is by the reflexive property of congruence. This was one of our givens that we added to the picture. And so we have the reflexive property of equality. And then, of course, that is going to be angle side angle as my shortcut. I immediately know that I'm going to have one of my shortcuts listed next to that. So these triangles are congruent by angle side angle. Okay? So why can I go back and then prove? What are we trying to prove? Ultimately, we're trying to prove that these parts, AC and AD, are congruent. I'm going to make a note that that is a part. I know that after I've proven the triangle's congruent, all of their corresponding parts are congruent. So from A to C ends up being congruent from A to D, because once I prove that these triangles are congruent, then their corresponding parts must be congruent. So CPCTC says, hey, these parts are congruent because the triangles are congruent. This always comes after you've proven the triangle's congruent. So that's by CPCTC. All right, my next class is about to come in, so I'm going to have to make another video later for the last 2 proofs.